Hey guys, this is Team 19. We have two team members, Tian Hongding and Qi Li. Today we're gonna talk about a project that we have been doing for this semester, which is Dota 2 win probability prediction. So this is our outline. We're gonna talk first about the technologies that we have been used. We're gonna talk about the data sets, the challenges, the findings that we have made, the business values for what we have done, and the demos for all the approaches that we made. And we're finally going to talk about the next steps and the follow-ups. So for the technologies, we have been using variable different kind of technologies. We used TensorFlow net, neural net library. We have used the item-based recommendation technique from the Mahout. We have used Mahout and Hadoop for all those projects. Also, we have been using machine learning programs like multinomial naive Bayes model and logistic regression model in R and Python. For the data overview, we're going to talk a little bit about what is Dota 2. But first, we want to let you see a video. So this is the Dota 2 value, and I hope that you can enjoy.
Much depends upon the hero. Would you be swift? Then for you I have speed beyond measure. Would you be strong? Then I can grant you the might to overpower any foe. Would you be wise? Then come closer and I will unlock your inner one. What does a hero truly mean? That is for you to decide.
So this is Dota 2. What a hero truly means, that is for you to decide. As we can see, there are two teams in Dota 2, which is called Radiant and Dire. Each team has 5 players, and each of the players choose one hero from a pool of 113 heroes. That is a lot of heroes, but that actually enhance the game's interesting and actually make the game popular and more people want to play it. As for the dataset, the uncompressed dataset is gonna be 2.94 gigabytes. That's a huge dataset, and we can extract a lot of information from it. So in this project, we have recorded 97,230 matches, and for each matches we have 1,125 variables. As you can see, there are hero informations, the money informations, and all different other information we have not been used for the project. And during the project, we have some challenges. We have the basically two most important challenges. The first one is the prediction model building. In this challenge, we have to face that the hero variable is neither categorical nor numerical, so it cannot be used directly. In this case, our solution is to use a neural net to learn it. And for the other point, there is going to be some prediction model comparison, and we have to think more on that. For other challenge, we need to understand how a player is going to win the game, and it means that we need to identify the factors that will increase the win probability. Which hero is going to be selected to increase the winning probability? We assume that the winners have similarities in choosing heroes, and our solution is going to be the recommendation system. So for the outcome, we have four different outcomes. We have the logistic regression model, which have the highest accuracy, being 68%. And by looking at their coefficients, we can find that the money and experience are crucial factors in winning the game. By multinomial naive Bayes model, we can get the accuracy of 65%, which is slightly lower than the accuracy of logistic regression. But in TensorFlow model, we can only find the accuracy rate of 58%, which suggests that it is hard to predict who will win by hero information only. And based on the item-based recommendation system, we found that some heroes are recommended more often than others. So talking about the business values, we can see that the Dota 2 esports competitors want us to do this kind of analysis, because if we can understand which kind of hero combination can have a higher win rate, they're gonna use this combination and win the game. And because of the prize pool of the game is up to 1 million, that is a lot of money that they can benefit from our analysis. And for the game development company Valve, they want to make the game unpredictable to attract more customers, which means they want to make sure that there are no such hero that's going to win a lot more than other heroes. And this is what they call balance. And how do they make it? They can use our program to analysis which hero has a higher win rate, and they can, based on that information, to do some change of the game. So finally, we're gonna talk about some demos of different approaches that we've used. Firstly, we want to talk about the TensorFlow neural net. This is a neural network graph or chart. As we can see, there are 226 columns, which indicates either the kind of hero has been chosen or not. If it is chosen, it is going to be the 1, and if it's not chosen, it's going to be 0. And for reading side, we have 113 columns, and on the other hand, the dial side, we have another 113 columns to indicate which heroes are selected. And on the very right side of the chart, we can see a Y value, which indicates whether the game is winning by the reading side or the dial side. If it's a 0, it means the reading side won. If it's the 1, it means that the dyer won. And based on that, we did a net structure based model, as we can see in this picture. But we want to make sure that you understand what we truly did, so we're gonna let you see this of the tensor board. So this is what we have done through the TensorFlow program, and it has the inner interface of what it's going to do and what it shows. So this is a tensor board chart, and we can see there's a large structure of the neural network. On the bottom side, there are two items that I want to mention here. One is the diode side and the X radian, which is the two data sets that we put into the layer. We use these two data sets to do a basic training, and we call it the hero layer 1. By recursion, we can do that again to get into hero layer 2, and so on and so on. We do a lot of different kind of layers, and we reduce the dimension of the data throughout the process, and finally we get the output layer, which is right here. And we found that the output layer only have two values, which is either 1 or 0, which is actually the prediction value of the outcome. So this is the TensorFlow. Also, we want to show you that the accuracy network of the TensorFlow. Here is the accuracy train chart, which indicates there are 100 different training, and after each training, it actually did a better job after more than 70 training, and it becomes to be pretty good at the 100 train, which becomes 0.58 accuracy. And there's other things that I want to talk about this new model. We can actually add more factors such as code and experience into the model as a new node. We want to show that they can be actually relevant to the winning side, but the result is not that satisfying. The test accuracy is only 0.52. It suggests that other factors may interfere with the learning process of the neural network, but the network process is too hard for us to understand. In the second demo, we're going to talk about the recommendation system technique. If the winner chooses a hero with ID I, then we say that he buys that hero, so item I is given rating 1. For example, winner 1 chooses hero with ID 2 and 113, then we say that the rating of these heroes will be 1. As you can see in this chart, for the game 1, there are 113 heroes, and 5 of them will be rated 1. Based on this recommending system, we can get a chart of it. So we can see from the recommended result, hero with ID 33, 49, 50, 67, and 100 are recommended high more often than other heroes, which might suggest that these heroes are probably too strong in this patch and they need to be balanced in next patch. Or picking them can actually lead to a better win rate. For the next step, we want to adjust the neural net model to find better accuracy rate. We also want to use the categorical similarities measures in the recommendation system, and we also want to gain more matches to train the model so that we can have a better accuracy. And this is the appendix, the things that we've been looking to, and hope you enjoy this project we have been doing. Thank you.